Assalamu alaikum warahmatullahi wabarakatuh. Today we're going to continue doing chemistry Regent for June 2018. We are in part B2. Say the general trend for first ionization energy as element in the period 3 are considered from the left to the right. So again the period is the row. So when I go from the left to the right, what's going to happen? The radius decrease. Electronegativity increase. As the electronegativity increases, the ionization energy increase. Why? Because electronegativity keeps the electrons close to the nucleus, so it needs more energy to break it down. Okay. Identify a type of strong intermolecular force exists between neutral molecule but doesn't exist between carbon dioxide. So carbon dioxide is C double bond O double bond O. Water is HOH. So if you look here, it's clear that we have hydrogen bond, and in the same time that's partial negative, that's partial positive. Here I don't have that part, so I have dipole, and I have hydrogen bond, and this doesn't exist in carbon dioxide. There was a structure for 2-butanal but. If you're looking for a reference sheet, it's it's mean 4, so here we go for that one. So here but means 4, and all means here alcohol, so I know I have OH for all. Now I go for my question. He said 2-butanol, so butanol means I have 4 carbons. He said 2, so 1, 2, 3, 4. So in position 2 I have OH, and the other are going to be hydrogen. So the final structure. Question number 54 through 56. He giving me a table for some silver compounds. So these silver compounds are silver carbonate, silver chlorate, silver chloride, and silver sulfate. Explain of term of elements classification why silver chloride is ionic bond. So silver chloride. So that's a metal. That's non-metal. So the bond between metal and non-metal is ionic bond. So I explained in the term of elements. Now, show numerical setup for calculating percentage of composition by mass of silver and silver carbonate. So look here, I have 2 times the silver, and the total mass formula is 276 and multiplying by 100. So the missing is the molecular weight for silver, which exists in the reference sheet periodic table. So it's 1.7, 107.868. So that's how I'm going to calculate the silver composition in silver carbonate. Now identify the silver compound in the table is most soluble in water. So we have Ag2CO3, AgClO3, AgCl, and Ag2SO4. Now what I'm doing, I'm going here for the solubility table. I have carbonate CO3. CO3 is a carbonate when combined with group 1 ion, so it's insoluble because he said group 1 and Silver is in group 1. Chlorate, chlorate here, all of them is soluble. Chloride, right here. The exception is silver, so this one is insoluble. Now sulfate, the exception is silver, so the only one soluble is chlorate. The only one soluble is the chlorate. So what does it mean? Silver chlorate is the one that's soluble in water. Question number 57 through 59. When cobalt 59 is bombarded by subatomic particle, a radioactive cobalt-60 atom is produced. After 21.084 years, 1.20 grams of original sample of cobalt-60 produced remain unchanged. Complete the numerical equation. So I have cobalt 59 plus something giving me cobalt 60. Now I don't have the reference sheet, but the answer sheet, but I'm going to figure it out. So the cobalt is 27, so that should be 27, 27. Now, what's plus 27 giving me 27? That's 0. What's plus 59 giving me 60? That's 1. Okay, I'm going for the reference sheet again. What is 0, 1? That's a neutron. 0, 1, that's a neutron. So now this is neutron. So whatever missing in the equation, whatever missing, you're going to find it in that equation. Okay. Now, based on table and identify the decay mode for cobalt 60. Cobalt 60. So I go for the decay table. He said table N. Cobalt 60. Cobalt 60 is here. So it's beta decay. So it's beta decay. Beta decay or electron decay, doesn't matter. Beta decay. Determine the mass of the original. So he giving me, it took 21.084. So I'm going for the same table. Cobalt I divided by 5271, which is going to be 4. So now I know I have 4, 1, 2, 3, 4. I know I have 40 halves. I know I have 40 halves. So I end by 1.2 multiplying by 2, giving me 2.4 multiplying by 4 by 4.8 multiplying by 2, it's 9.6. After that, multiplying by 2, 19.2 grams. So that is the original sample of cobalt 60. Okay. Based on the graph. So that's a sample molecular substance starting gas at 260. So that's gas. Okay, that's liquid and that's solid. And these are the intermediate stage, so it has gas and liquid, and this has liquid and solid together. You have to understand the curve. Okay. Determine the number of minutes that's a substance. So I said again, so that's gas, that's liquid, that's solid, liquid plus solid, gas plus liquid. Now it says in the liquid phase only, so it's that amount. So that's 11 minus 6 giving me 5 minutes. Okay, now the second part, compare the strength of the intermolecular force within the substance in 180, so it was gas, and 120, so it was liquid. So we understand that the intermolecular force in liquid is more than the intermolecular force for gas. That's why the gas doesn't have a shape or cannot take a shape, and the molecules are far away from each other, while the water taking the shape of the glass, and at the same time, you can see it because the molecules are close together. Okay. Describe what happened to the potential energy in dE. So look here. dE, we said in dE, I have solid plus liquid. So what does it mean? The kinetic energy is going to be the same. Kinetic energy is going to be the same in through this process. Why? Because I still have moving atom, and I still have the solid and the liquid gas in the same phase. So the kinetic energy is going to be the same. But what's going to happen to the potential energy? Potential energy is going to decrease. Why? Because now instead of having movement is going to stop moving and being close together. So the potential energy, because it's losing energy, so the potential energy will decrease. Okay. Question number 63. So 65, giving me some information. The diagram representing a cylinder with a movable piston contains 16 grams of oxygen at 297 K and have atmosphere. The oxygen has a volume for 24.5 liters. Determine the number of the moles of the cylinder. Uh, uh, Giving you that the ground formula mass for oxygen is 32. So he said you have 16 grams. So number of moles equal to given weight over the ground formula mass. So what does it mean? It's 16 divided by 32, giving me half moles. And that exists in your reference sheet, last page. Number of moles. Question number 2. State the change in both pressure and temperature of the gas in the cylinder that would increase the frequency of collision. And so increase the frequency of collision either gaining temperature or decreasing the volume. And decreasing the volume is going to be through increasing the pressure. So increasing pressure, increasing temperature is going to increase the frequency. Why? Because increasing the temperature is so the molecules is going to have higher energy, so they're going to move fast, so it's increasing the probability of collision. At the same time, when I increase the pressure, so I decrease the volume, so the molecules being or the atoms being close to each other and being close to each other, so I increase the probability of collision again. Now, show the numerical setup to find the volume, the mass, and the cylinder. Okay, so I use the combined gas law. B1 V1 over T1 equal to B2 V2 over T2. You want a numerical setup to find the volume. So V2 equal to, I multiply by T and I divide by B2. So B1 V1 T2 divided by B2 T2. Now, what was the pressure first? Half. What was the volume with the volume first times 24.5? What was the temperature later? That's 265. Now, what was the second pressure? 1. What was the temperature first? 298. So that's the numerical setup, and I use the combined gas law. The combined gas law, you can find it here. Combined gas law, that's the one I used. Hope you understood, and that's the end for that part. Assalamu alaikum wa rahmatullahi wa barakatuh.